Hello guys, so welcome to another discussion video with Engineering Mechanics 1. Alright, so at this point in time is I'm I'm confident nga you are already mastered or medyo kabalo na mo on how are we going to solve for system resultants, diba? So that was our previous discussion na topics. So at least karon kabalo na mo on how to solve moments for system resultants, all right? And especially how you are already have the idea on how are we going to reduce simple distributed nga loadings nga kaya nato siya analyze, di ba? Because again, katong nga mga topics that we have discussed in the previous module is we will be needing that on our succeeding nga mga topics that we'll be discussing until the remaining topics of this course, di ba? So if ever nga medyo di pa mo confident with the topics before, then I guess the videos are still available naman sa YouTube, diba? So you can just replay it and then recall the topics that we have discussed before, especially if need na to siya in this module or the succeeding pa nga mga topics. Alright, so our topic for this video or for this module is all about equilibrium of a rigid body. So medyo we're starting to what you call this, medyo musulod na ta to basic structural analysis because again, whatever you have learned in this module is very basic siya. If ever maglisod mo diri nga module, especially if mo to na mo sa inyong higher na mga courses, alright, especially sa strength of materials, theory of structures. So if ever maglisod mo diri, medyo maglisod jud sad mo dito. Alright, because this would be the basic, especially okay, so ang atong mga i-discuss during module would be what are the conditions of rigid body equilibrium, and then how to draw free body diagram. So I guess you already have the ideas on how are we going to solve for free body diagrams. Except lang, ang atong na-discuss ng free body diagram before was all about equilibrium of particles. So we are just dealing with particles lang, like as a very small particle lang with a considerable na weight. Pero there, since we are dealing with rigid body, so most of the time we are dealing with body itself. Okay, kung ano sa ang body, like beams, frames, columns, and all. Alright? Then lastly is we will be dealing equations of equilibrium. Heads up lang is disclaimer, ang ato lang i-discuss in this module is all about coplanar equilibrium lang. Okay? Because what do you call this? Three-dimensional na equilibrium of rigid body is very kung ano siya. The same concept lang, okay? The same concept lang, but you are nag-base lang gihapon na siya sa atong three body gani what do you call this? Equilibrium of a particle nga three-dimensional. So medyo the same lang siya dito. Ang kalahian lang niya is naka-i-add nga mga reactions. But again, medyo mas sayon the same lang gihapon siya kaya ato mo siya i-discuss diri sa module 4. Okay? Then ang last topics na to with kaning remaining two topics, kaning 2 and 3 force members, tapos constraints and statistical determinacy, that would just be a very rough lang discussion because that would be a very short lang, okay, explanation. Okay, so the objective of this module is, first is we're going to develop the equations of equilibrium because again, we need to start with the equations of equilibrium. So medyo di kayo initially lisod because nakasugat naman mo equations of equilibrium, and we are just going to use that here. Alright? Then introduce the concept of free body diagram for rigid body. So naatay difference actually with free body, FBD for particle and then FBD for rigid body, and you will understand that later as we go along with the discussion. Alright? Then lastly is solve rigid body equilibrium problems using the equations of equilibrium. So okay, so first is what are the conditions for rigid body equilibrium. So here we are going to understand the different conditions in analyzing rigid body equilibrium. Okay, so first condition, the rigid body can be subjected in any external forces and couple moments, and we all know that, diba? Based sa mga previous discussion, a body can experience a force, tapos can also experience moments, and also a combination of force and couple moments. So system siya, external forces. Alright? Now, since we are considering the body as a rigid and whole, okay, whole siya, meaning buo. Okay, for example, natay beam or, for example, dere, kaning particle. This particle is whole man siya, ato siya i-consider as tibuok. Alright? And then rigid because, again, the course is rigid body. So, rigid siya. Now, it is subjected to force and then also couple moments, right? So kani, kung ato drawingon ang iyahang free body diagram diri is we are only to consider the external forces. Okay? External forces lang. And we are not going to consider the internal forces acting on the inside. Okay? If we are going to, since whole man ni siya, buti pasabot, ang atohang member is kanang rigid. Okay? Tibuok siya. So wala nag-ana-ana dito ang imuhang mga particles sa sulod because again, kung buo man ang imuhang body, so therefore all the internal forces are canceling out. So I hope you understand. So if ever we are going to consider the FBD of this one, so we are just going to consider only the external forces. If that will be discussed in module 6, all right? Ang internal force, ang atong mga internal forces. So kanang internal forces ato lang na siya makitaan if we are going to cut a cross section, meaning ato ikat ang ato ang body para ma-expose nato ang mga particles, para makita nato siya ang iyahang mga internal forces. Pero again, since we are considering this body as a whole system, di nato makitaan sa internal forces. So ang ato lang i-consider diri is atong mga external forces. Second is, for a rigid body to be in equilibrium, the equivalent resultant force and equivalent resultant moment acting on the body should be equal to 0. So we all know that to be in equilibrium, all the resultant forces and moments should be equal to 0. So your resultant forces or the summation of your forces should be equal to 0, and then the resultant moment or the summation of moments about point O is equal to 0. So muna siya. So if we are going to break this into its components, so that would be summation of forces x is equal to 0, then summation of forces y is equal to 0. Then lastly is, although in reality that all bodies deform in subjects to load, di ba? So kabalota nga maski unsa pa nakaligon ang usa ka butang, it will deform gyud na siya. Mo deform gyud na siya in reality. Pero during our topic is we are going to assume, alright? We are going to assume that the body will remain rigid maski mo apply pa kadihang external forces. And also, ang iya po gibasihan diha is there are some materials, okay? For example, concrete, for example, okay? Ang atong concrete is tungod sa very strong siya in compression, alright? Because concrete is very strong in compression. Medyo gi-assume siya as rigid nga naman, because the deformation, although naagyo siya deformation, it is insignificant, meaning dili kay siya matter tungod sa a very small deformation lang nga dili kay siya significant. Okay, that is why concrete or steel, because steel is very strong in tension man po, di ba? So although naatay gagmay nga deformations, they are already assumed as rigid because gagmay lamang gid kayo siya compare sa imuhang total nga strength, so mga 0.0001% nga percentage ang imuhang deformation. So, mo na siya in reality. Pero, we will discuss that in your next course that would be mechanics of deformable bodies. You will know that all materials will deform yun na after the application of your external forces or loads. Alright? So, those are the conditions of rigid body equilibrium. So, I hope nga klaro siya. Okay? So here, equilibrium in two dimensions is, we are only be discussing equilibrium in two dimensions. But then again, I will be giving handouts, alright, or the copy of my reference, okay, so that you can read kung yun sa man jud pag-solve, what are the concept nga gigamit to solve equilibrium in 3 dimensions na pod, sa 3 dimensions. But again, the same lang na siya, almost the same concept lang na siya sa atong previous nga topic, that is the equilibrium of a particle siya, okay? Particle in 3 dimensions. So almost the same lang gyud gihapon na siya. Okay? So Dere, since we are dealing with equilibrium in two dimensions, for example, okay, all forces and moment system acting on a rigid body will be analyzed by projecting the system into a single plane or often called as coplanar force system. So, ato siya analyze as coplanar lang yun, as in plane lang siya. For example, okay, if you're going to analyze this airplane, for example, okay, so if you're going to draw the free body diagram of this one, of this airplane, is yun na siya pagka-drawing. The weight, okay, the weight is acting at the center of gravity, kanang G nakabutang, meaning the total weight of your plane is acting on this G, kabalo man sa center of gravity, di ba? So diha ang iyang center of gravity. Tapos, ngano tuti man eh. Because again, if you are going to consider three-dimensional, okay, if three-dimensional, di ba kaning airplane na to is duha ka ligid sa likod, tapos usa ka ligid sa tubangan, di ba? So, there is, since we are analyzing this as coplanar force system, so medyo, ang katong sa likod is wala na to siya ipakita, di ba? Because again, we are dealing with two-dimensional lang, or plane. So, nga naman ang 2T, because again, they have two tires. Duha na sila kaligid sa likod, dire one lang, usa lang siya ka-R, because usa ra man giligid sa tubangan, di ba? So ina na siya pag-analyze. That is your equilibrium in two dimensions. So dapat we are going to project it as a single plane or coplanar force system. All right? So free body diagrams. So I guess nga ako na siya na-introduce before sa inyo kung unsa ang free body diagrams, pero ang ilang difference diri is we are dealing with rigid body na. Okay, we will understand that later. So first is we're going to effectively represent a rigid body force system as a free body diagram to specify all the knowns and unknown forces acting on it. So that is really the purpose of your free body diagrams, di ba? To expose kung kinsa ang known o kinsa pud ang mga unknown forces nga naa sa imuhang body. So katong ka sa if before nag-discuss tag particle, karon we are dealing with body. All right? Then identify commonly used supports and represent their equivalent reactions on the free body diagram. So karon, okay, makabalo na mo kung unsa ang mga different types of supports, because again, you will need that along the way. So maski fourth year na mo, dapat naka-tie up na sa inyo ang different types of supports. Okay, kabalo na mo kung unsa ang mga supports nga pwede gamiton sa inyong structural analysis. Alright, so diri na nato siya i-discuss. So let's just recall that the free body diagrams is a sketch of the outline shape of the body, which represents it as being isolated or free from its surroundings. So from the word itself, free body meaning free siya. Wala siya naka-attach maski asa. Okay, imo siya i-isolate ang imuhang supple member, imong beam, imong frame, okay, imo siya i-isolate. Pero take note that you should also show all the forces and couple moments that surrounding exert on the body. So whatever forces or moments, external moments and forces acting on the body, you should always include that in your sketch. Okay, although imo siya free, okay, gitangtangan nimo siya mga supports, okay, tangtangan nimo siya og naka-isolate siya, okay, naka-isolate ang imuhang member. Pero again, you need to show all the forces and the couple moments acting on the body. Okay, so that these effects can be accounted for when the equations of equilibrium are applied. Again, you will know that later if we have some examples. Alright, so a thorough understanding of how to draw a free body diagram is of primary importance for solving problems in mechanics. So kung dili ka kabalo kung unsa ang paghimo ang free body diagrams, again, mabata ko ingon before nga dili ka ka-solve kung wala kay free body diagrams, especially na pud diri because lisod na diri imaginon. Okay, kaya ra siya if equilibrium particle, kaya ra nimo siya mata-mata. Okay, that is was sa inyong mga exams. Okay, sa inyong mga exams, I did not consider answers without free body diagrams because again, yun sa man nimo pag-solve kung wala kay free body diagrams, di ba? So particle pa ganito, how much more diri sa ato ang rigid bodies. Okay? So no equilibrium problem should be solved without first drawing the free body diagram. So muna ako ingon nga free body diagram is the first step. So as to account for all the forces and couple moments that act on the body. Okay, so general rule. What are the different support reactions? So first rule, if a support prevents translation of a body in a particular direction, then the support, when ato siya, di ba again, we are going to free body diagram, ato siya i-free body ang atong member. For example, ang kaning member is naa siya support, ngayon ani nga type. Okay? Kung ang kani nga support is prevent translation of the body, okay? So ato siya, if ato siya himo ang free body diagram, di ba? Kung mag free body diagram tangtangon na to ang support. Okay? But then again, free body diagram is dapat imo ipakita ang mga forces acting on the body. So in this case, since nag-prevent man akato nga force nga imong gitangtang, nag-prevent man siya og translation, you need to put force there. Okay? Murag siya representative sa imuhang free body diagram. Alright? So on that specific direction. So for example, roller support. Since the support only prevents the beam from translating in the vertical direction, okay, di ba kaning roller na to dire? Roller na siya, mura siya julin ba? Okay, marble. So since kani nga beam is iya gi-prevent nga dili siya mo ari paubos, okay, dili siya mo down. So therefore, if ato ni himo og free body diagram imong roller, it will exert a upward force. Kaya again, gitungtungan man siya, di ba? So kung gitungtungan ka, for example, kung gitungtungan ka sa imong nag-arsa ka for example og kahoy, so therefore ikaw nag-exert ka og force pababaw para imong dadon ang imong kahoy or imong beam for example, di ba? So that is because again, your roller is preventing this beam to translate about the y-axis. I mean, yeah, vertical, sa vertical nga mode nga direction. So therefore, dili man siya mo up or down. So therefore, kani nga roller is have a vertical na force or your reaction. Alright? Next. Our example for this is your roller support na ni siya makitaan sa ato ang mga dagko kay nga mga tulay before. I mean mga sa gawas ni siya usually. Pero napo ni siya sa mga expressways, alright? Sa mga dagko nga mga tulay pero diri ang common man diri sa ato is beam girder nga mga bridge, okay, or mga slab bridge mo na common nato makit-an diri. Pero sa mga, because again we have different types of bridges, so most of the time gamiton ni siya sa mga trusses nga mga bridge, okay, truss bridge tapos cable stayed bridge. Okay, so this is your roller support for your girders sa imuhang bridge. So this is a roller or a rocker. So that is an example of a actual na support. Alright? Then this is also your kani, this is also common mo na atong common diri. We have a what do you call this, pylon or pier, okay, for example. Kana siya ang or column post, okay? Kana siya ato na siya itungtong ang atong mga girder, ato na siya itungtong sa ato ang pylon or support. So that is mura siya somewhat the same with roller support. It prevents translation in the vertical direction. So you will have to exert a upward nga reaction diha, or I mean reaction about the y-axis. Next is pin or hinge support. I guess kailan mo siguro ta og pin kanang sa atong mga bisagra, alright, sa ato ang sa pailain. Daghan tay nakit-ana ni nga pin or hinge support. For example, this is your leaves pin. So ang iyang itsura karon is ngari, matuyok-tuyok na siya. Okay, matuyok-tuyok na siya. Kani, imo na siya matuyok-tuyok ba doon dito. So since kani nga force, kani nga support, kaning hinge na to, it prevents translation. Di man ka makamove diri x, di po ka makamove diri sa y. So therefore it prevents the body, alright, in translating in both x and y direction. So if ato siya himuag free body diagram, mo exert siya og reaction about y and also reaction about x. Ba kay duha man ang iyang i-prevent the translation. So we have pin support. What you call this? It prevents translation of a body in particular direction, specifically x about x and about y nga direction. Ngano di makaka-resist to movement because again pwede maka-movement diri because again this is spin, so pwede nimo siya tuyokon diha, so wala kay resist nga movement. Next na tong rule is this is an example of a pin nga support sa imong cable, mga cable stayed bridge. Alright, so inanan na siya pagkahigot, pwede na siya motuyok dito, pero dili nimo siya pwede ma-move or translate about the x and y direction. Also kani siya ang ato ang mga connections or bracings, so nakapin po na siya. So that is an example of a hinge or pin support. Second rule, okay, kaganina is prevents translation of a body. Karon is if the rotation is prevented, the support will exert a couple moment on the body. So for example, fixed connections, mo na ang pinaka-restrictive way. So ang ato mo yung pinakaligo na itong support that is available, that is your fixed connections. Meaning, alright, so fixed siya, meaning dili nimo siya maibot, dili nimo siya ma-move, also di po din nimo siya matuyok. So therefore, if nag-resist kag translation, di ba? Fixed support, resist translation, di man ka ma-move, dili nimo siya ma-move, di po din nimo siya ma-move pa doon dito. So about why it will resist a vertical force. Tapos about the horizontal, it will resist a horizontal force. Then since dili nimo siya matuyok, alright, dili nimo siya maka-apply og moment diha. Now it will resist a moment here. That is why your fixed connection is a very restrictive nga way because it prevents your three nga reactions. That is your vertical, your horizontal, and your moment ng mga reactions. So that is an example of your fixed. What are an example of your fixed? For example, sa ato ang mga concrete ng mga structures. Alright, if ever mabuhusan na ni siya, ang ato ang beam and then a column, si beam, si column, ug si slab, since monolithic naman na siya, di ba? Kailangan tag monolithic, meaning kausara siya nabuhos. So therefore, if monolithic na siya nga pagkabuhos, it will provide a fixed connections sa atong RC structures. Diri po sa atong steel structures, ang ato ang fixed connection usually welded. Okay, kung naka-weld na siya, meaning ato siya gimelt tapos nag-dry, nag-cool siya. So therefore, one material na siya. So therefore, fixed na siya. So it will prevent movement and then force reactions. So that is an example of a fixed reactions, okay, or fixed support or fixed connections, okay? So these are the different, ato siya sa tagsaon na lang, these are the different support reactions that is commonly used diri sa ato ang discussion. First is cable. I guess nga ako na introduce before si cable. Your cable has only one unknown. So usara na siya ka-unknown. So the reaction is a tension force. Okay? And we all know that tension is always away. Okay? Acts away from the member in the direction of the cable. So if this is your cable, so therefore since naman diri mo support, okay, it will point away from di naman imong member, okay, this is your member, so therefore that will point away from the member. So one unknown lang na siya. Next, weightless link or spring. So it will give you also one unknown. The reaction is a force which acts along the axis of the link. Now, since this is a link, it can be a rod or it can be a spring, di ba? Spring can be compression or tension, di ba? So it can be tension, pwede po siya compression, so maski depende sa imuhang pagkaso. Basta it can be tension or compression. That is for your link or your spring. Next is your roller support. So your roller is a reaction force which acts perpendicular to the surface. For example, this is your surface, okay, that is inclined theta, and this is a roller support. So mura siya ligid, all right, or wheel gagmay nga mga ligid. So therefore, your reaction there would be one force, so that is one unknown, and it is always perpendicular to your point of contact. So this is perpendicular. Alright, so muna siya. The same also with your rocker. So pare almost the same lang na sila explanation. One unknown which acts perpendicular to the surface of the point of contact. So this is your force, so this would be perpendicular to your point of contact. Next is smooth contacting surface. So, mo ko example ganina sa girder, di ba nga to ang mga tulay, for example, if this is your pylon, for example, this is your post. Ang ato ang mga girder, isa to na siya itong diha, itong. So, therefore, kani nga port point dere would be a smooth contacting surface. Okay? Nakatungtong lang yun na siya. So, that would be it will give you a one unknown that is always perpendicular to the point of contact. So almost the same sa imuhang ruler. Ngano nagisgot tag smooth contacting surface? Because again, if we are going to consider rough, okay, smooth siya because again, if mahimo na siyang rough, we will now have friction. Okay? Now kung mag-friction na ta, it will be a different, separate nga discussion. Friction. But since again, wala pa man tamo discuss friction, we will consider a smooth nga reaction or smooth nga surface diri para wala tay reaction, wala tay friction nga mahitabo. All right? Next is Next is roller or pin in confined smooth slot. So almost the same lang gid gihapon na siya. One reaction since mo prevent man siya og pwede man ka mo move dito, pwede pud ka mo moment dere. So ang imo harag gi-prevent nga translation is kaning nga part dere. Alright? Kaning nga part dere perpendicular to your slot. Okay, perpendicular to slot. Therefore, the resist ka direct translation, it will give you a reaction force perpendicular to your slot. Next is pin connected to a collar smooth on smooth rod. So therefore kani ga-resist kag moment, pwede ka mo moment diha, di ba? So pwede ka mo moment tapos diri pwede pug ka mo ka-move diri, di ba? Either up or either down, so pwede ka maka-move. Ang ilang gi-resist is ang kaning nga part diri, di ka pwede maka iswag-iswag. So that is why you will resist a force here. Okay, perpendicular to your rod. This is your rod. Okay, if this is your rod, that would be perpendicular to your rod. The next is smooth pin or hinge. So ako na nag-discuss ganina, if you have a pin or hinge connection, you have two unknowns because the reactions are two components. It would be your horizontal force, your horizontal component tapos your vertical component. Dili man ka pwede maka-move about the horizontal tapos about po the vertical. So therefore you have two. Next is fixed connected to a collar. So diri, okay, since dili man ka pwede mo moment diri because that is fixed connected man, di ba? Dili pras ka ganina nga you have this is a pin connected, so pwede ka maka-moment. Diri is medyo naka-fix naman siya, either welded ni siya. So therefore dili ka maka-moment diri. Okay, dili ka maka-moment, so therefore nakay moment. Diri maka-move man ka diri, so pwede na siya. Ang imuha diri is ga-restrict na siya diri pod. So this will have a force pod. So that is why we have two unknowns. So I guess daghan na kitag mga support. Then lastly is your fixed support. So ako na siya naingon ganina that your support, fixed support resist moment. Okay, di man ka maka-moment diri, so you have moment. Tapos you have vertical reaction. Tapos you also have a horizontal reaction. So at least if you already know the supports, makabalo na ta on how are we going to use your free body diagrams. So we will deal that. We are going to use examples for that para mas maka-gets. Okay, so lastly is weight and center of gravity. So kabalo naman taon say weight, di ba? So the particles of a body that is subjected to gravitational field forces possess a specified weight. So ang atong body is natin mga particles. So kanang mga particles na po na sila kagalingon nga weights. Now to get the simplified, so ang resultant niya ba sa nilang tanan murag ang ilahang overall ng mga weight lang is called as your simplified weight or your weight of the body. That would be your resultant weight. Then kanang resultant weight or that is your weight, the location of that is located at the center of gravity. So kaning center of gravity is we will discuss that in module 8. So if for uniform body, for example, prismatic lang, mga beam for example, or kaning uniform ba, okay, equal uniform cross sections all throughout the length. So usually ang centroid for that one is atong center of gravity or G is at the geometric centroid. For example, natay uniform nga beam. We have a uniform beam that has a length of 4 meters, for example. This is 0.1 meters, for example. Okay? 0.1. So, since this is a uniform body, the center of gravity is already at the centroid. So, if this is centroid, katunga diri, that would be your 0.05. Katunga diri, what would be your 2 meters. So, therefore, diha mo act ang ato ang weight. This would be your center of gravity. Or that is also your centroid. Pero if dili ka wala ka taga the given is non-uniform body, so dili siya uniform, si center of gravity or G will be given para mas madali. Because again, mag-discuss mo tag center of gravity on the next modules. Okay, so that's all about your free body diagrams. So idealized models, for example, sa ato ang mga in reality is especially if mag-design ka og buildings or structures, you start your analyzing is mag-analyze pa ka sa slab, okay, sa ato ang slab sa sahog. Okay, example kaning nga truss diri is ato na butang og sahog diha. So ang ato ang girder karon kani nga girder, okay, kana nga mga girder is top view na siya. Suppose example, this would be our girder. Na siya gitawag og tributary area. Okay? Tributary area, you will encounter that soon. Okay? If this is your girder tapos this is your slab, ang imong slab is nara na siya, ang imong girder is nara siya gi-carry nga load within its tributary area. So therefore na siya gi-carry nga load. Okay? And that load is in kilopascal as what I have discussed in the previous video, kilopascal na siya. So since kilopascal man na siya, para mas dali nato siya ma-analyze as a girder, okay? Diba ang girder nato diri is nakaana man na siya. Kani, ato na siya gi-drawing diha. So para ma-analyze nato siya ang kilopascal is again, ato na siya gi-multiply diri, di ba? Para mahimo siyang one axis na loading. So therefore ako na siya i-multiply diri your width or ang iyahang tributary width para mahimo siyang distributed nga loading. Okay? So maina na siya. Then if na naka-distributed loading, for example, this is kilonewton meter man ang unit, di ba? So if you already have this distributed loading, tapos you have here a support, since gitungtong raman na siya, we can use a ruler, or tapos this is a pin, for example. Okay, naka-pin na siya. So we can solve here a reaction. Okay, makasolve the reaction. Then ang kaning reaction, it will be transferred to our beam. Okay, this is joist day, sorry. This is our joist. Ato siya i-transfer sa ato ang girder. So kung whatever reactions nga makuha nato diri, mo ni atong i-transfer diri sa ato ang girder. Tapos maka-analyze na po ta lahi. So ina na siya pasa-pasa sa mga loading. So if you already have the idealized model, for example, kani siya, okay, gitungtong raman na siya, so it will have a reaction force F diri. Okay, kana sila tulo. Diri, this is bolted man na. For example, this is bolted. Now, usually sa atong steel construction, if that is a bolted connection, you will analyze it as a pin nga connection. So this is a pins connection. Dire, since gitungtong raman siya, okay, gitungtong raman na siya, you will analyze that as a ruler support. Okay, so this is a pin, tapos this is a roller support. So that is an example of an idealized model. So kabalo ka mo relate siya in the actual na construction. Dili pod, okay? Idealized lang. Example, magtungtong diri nga tao, that would be your P, load P, tapos the weight of this crane here or the boom itself is acting on the center of gravity, which is your G. Tapos you identify the connections. So nakay force diri, pin connected ni siya. This is also pin connected. So you will have the values of these forces. Okay. So nga rin na siya mag-start sa imong free body diagrams. Okay. So draw the free body diagram of the uniform beam shown. The beam has a mass of 100 kilogram. So this is a beam which is called as a cantilever beam, meaning this is a cantilever beam. Kaya nga naman, this is fixed. Alright? This is fixed. Tapos, this is a free end. Nagbitay siya. Alright? So, nagbitay siya. So, we know that since this is what do you call this? Ato na siya naon. Since, again, free body diagram, ato i-free ang ato ang beam. Okay? Ato na i-free ang ato ang beam, since we are going to draw a free body diagram. So, muna nato beam that has a dimension of 6 meters. So, if ato na siya na-isolate or ato na siya na himong free nga body, alright, we are going to what you call this, show. Okay, ato ipakita ang mga forces acting on the body. So, first of all is we have this 1,000 Newton. Okay, 1,000 Newton nga force because that is an external force. Then, okay, please take note that this is a support. Okay, that is a support. So therefore, we need to consider the force or the reactions that is exerted by the support because ato man na siya gitangtang. Okay, ato man itangtangon nga support. Pero if ato siya tangtangon, you need to replace that by the equivalent nga reaction. So therefore, dire, since this is a fixed support, naa siya resultant ato siya ng AY, meaning reaction at A vertical. Tapos we already have this AX, okay? Meaning horizontal reaction at A. Tapos, since fixed man ni siya, it resists movement. That would be your M. So, if na free body diagram, okay, na MA, na AX, AY, so, makasolve data sa imuhang mga ano. So, this is an example of your free body diagram. Alright? Then, always consider the sign convention. Okay? Muna natin consider the sign convention. That would be your, later na lang. Ito siya discuss later sa ato ang next nga discussion. Sige na lang, AX. For horizontal, we need to assume that horizontal forces should be to the right. For the vertical forces, upward dapat na siya. Tapos for moment, that should be clockwise. Positive, this is positive, this is positive. So, muna ito mga hinunduman if you are going to draw your free body diagrams. Okay? Next is two smooth pipes, each having a mass of 300 kilograms, are supported by forked tines of the tractor in the figure. Draw the free body diagrams for each pipe and then both pipes together. So, ato tagsa-tagsaon daw, tapos together put. Okay, so let's start with pipe A. Okay, for pipe A, for example, pipe A. So we know that this is inclined at 30 degrees. Alright? So, for pipe A, ato man na siya, okay, together lang sa. Okay, we are going to consider this system as a whole. Kaya naman, para dili na to makita ng mga internal nga loadings. Okay? Para dili na to ma-appeal ang internal loadings, we need to consider this figure as a whole lang anay. Alright? Oh, sorry. Assume lang tayo nag-abot na sila. Sorry na good. Okay, muna siya. This is 30 degrees. So if we are going to remove the supports, okay, please take note that this is contact, okay? Contact ni siya. This is also contact force. This is also contact surface na siya. So if ato tangtangon siya at if ato himuon ang free body diagram, it will give us this one. This would be contact dire. Normal force 1. Okay, perpendicular man dapat, di ba? If this is your one, perpendicular dapat na siya sa imuhang, okay, imong surface. Diri pod, since contact man po ni siya, this would be our N2. Contact po ni siya, this would be our N3. Meaning N, meaning normal. Tapos, we have the weight. Weight is always acting downward yun na siya. Downward, sorry. Downward. That is 300 kilogram. So if you have to convert that to newtons, yung multiply lang ka og 9.81. The same po sa imuhang B. That's 300 kilogram. Okay. So kana siya, this is the free body diagram if we are considering the pipes together. Okay? Meaning usa sila, okay? Wala na sila gibuwag. Kay para dili mo gawa si internal forces. Kasi what was about saying internal forces? Kay if you are going to separate that, we are going to do that separately. This is our pipe A, for example. Di ba si pipe A is na siya normal dire, N1, tapos na diri ang weight nga 300. Tapos naabot ta diri normal na N2. Please take note nga kani sila duha is na po na sila contact. Okay, na po na sila contact together. Na if we are going to separate them, okay, ato sila buwagon, mugawas na po ni siya nga reaction. Okay? Mugawas na po ni siya nga reaction. Meaning the reaction of A towards, the reaction of B. This would be the reaction of B towards A. Meaning nagtungtong si B, murag gitod si A ni B, di ba? Kay nagtungtong ni siya dire. Same is true with sa usa. If you are going to isolate B, di ba si B is we have normal 3 dire. Oops. That would be your normal 3. Tapos the weight itself, that's 300. But again, kani siya nga part dire is gitod si B na pod is murag gitod siya ni A. Okay, mo siya third law of Newton gani nga kung nag-apply ka diri nga force, so obviously napoy mo apply nimo nga same magnitude but opposite direction. Okay, so kung murag si A dire is murag gi-push pud si B pababaw. So medyo inana siya. That is the reaction of the reaction of A towards B. So this would be pipe B or pipe B. Tapos this would be your pipe A. So inana siya. That is your free body diagram. You need to show all the forces that are acting on the body. So medyo inana lang yun na siya. Okay? So anyway, free body diagram naman na siya. So you will understand that later if na natin yung mga examples in equilibrium nga problems. Okay? So that's the end. Introduction naman to siya. Okay? On what are the different types of supports. Tapos your quiz number 7, that would be advanced nga knowledge. Okay? So very simple lang ang mga problems good. Okay? That is advanced nga reading. Okay? Please do advanced study about the equilibrium of rigid bodies nga topics. Tapos that would be the coverage of your quiz number 7. Very simple lang good because that would be di pa man nato siya i-discuss. Okay, so before we discuss, we need to have a quiz first para mas makagets mo. Alright, so I guess let's just end the first part of this discussion video and see you on the next video. Bye.